Is it permissible to install single-conductor cables in a ladder-type cable tray with more than 2 layers? Further, did you know that determining the size or width of the ladder-type cable tray is not by percentage fill but by the total diameter of the cable? Hello everyone. In our previous video, we covered the sizing of cable trays for multi-conductor cables rated at 1000 volts or less, installed in ladder-type, ventilated trough, and solid-bottom cable trays. In this video, we'll focus on determining the maximum number of single-conductor cables rated at 2000 volts or less installed in a single ladder or ventilated trough cable tray, as specified in section 392.22b. We'll also go through fill calculations to help clarify these concepts. So, let's get started. As outlined in section 392.22b, the number of single-conductor cables rated for 2000 volts or less that can be placed in a single cable tray section must not exceed the specified limits. These single conductors or conductor assemblies should be evenly distributed across the cable tray. This requirement applies to both aluminum and copper conductors. The purpose of this section is to regulate the number of single-conductor cables rated for 2000 volts or less allowed in a cable tray section, ensuring they adhere to the specified size and distribution guidelines. Proper distribution is crucial to avoid potential issues. For example, if a cable tray holds 4 single-conductor circuits, each rated for 200 amps, and these cables are not evenly distributed. For example, all phase 1 conductors are placed next to each other. The current carried by these conductors will generate magnetic fields that may induce voltages in nearby conductors. This can cause additional heating due to eddy currents, increasing the risk of overheating. Additionally, uneven distribution can lead to phase imbalances, which may cause voltage fluctuations, increased losses, and even physical damage to the conductors over time, particularly during installation or maintenance. Therefore, it is essential to properly distribute single conductors in a cable tray to maintain optimal performance, ensure safety, and enhance the overall reliability of the electrical system. It is important to note that these requirements apply to both aluminum and copper conductors. Regardless of the material, the same size limitations and distribution guidelines must be followed. Section 392.22b(1) is for single conductors, rated 2000 volts or less, in cable trays installed in ladder or ventilated trough cable trays. Where ladder or ventilated trough cable trays contain single conductor cables, the maximum number of single conductors shall conform to subsections 392.22b(1)(a), 392.22b(1)(b), and 392.22b(1)(c). Subsection 392.22b(1)(a) states that, if all cables are 1000 kcmil or larger, the total sum of the diameters of all single-conductor cables must not exceed the width of the cable tray, and the wires must be installed in a single layer. However, conductors that are bundled together to form each circuit group may be installed in a configuration that is not limited to a single layer. As per this section, a single-layer installation. If all the cables in the tray are 1000 kcmil or larger, they must be installed in a single layer in the tray. This means the cables cannot be stacked on top of one another, but instead, they must lie side by side, in a single row. The summation of the diameters of all single-conductor cables must not exceed the width of the cable tray. Therefore, the minimum width of the cable for a single conductor installed in a ladder or ventilated trough cable trays shall be at least when all single conductors can be laid in a single layer. However, in the last sentence of the sections, when single conductors that are bundled together to form each circuit group may be installed in a configuration that is not limited to a single layer. For example, a cable tray holds multiple single conductor circuits. In Figure 1, the single conductor is bundled together, however, this does not form a circuit group. This configuration can cause induction heating, which does not comply with this section, while Figure 2 shows the allowable configuration of a bundle together. This configuration forms a circuit group. A common example of bundling involves arranging 3 single-conductor cables in a triangular shape, known as a trefoil. For 4 single-conductor cables, however, the cables must be arranged in a rectangular formation, with each circuit group properly separated. This arrangement ensures optimal performance, maintains safety, and enhances the overall reliability of the electrical system. What is the minimum width required for a ladder-type cable tray when it holds 5 single-conductor circuits, each rated for 550 amps, with a cable size of 1000 kcmil THW per circuit, all laid in a single layer? The outside diameter of cables can be found in Chapter 9, Table 5 of NEC, or you can use the manufacturer's catalog. The outside diameter of a 1000 kc mil cable is 1.502 inches. With 15 cables in total, their combined outside diameter is 22.53 inches. To find the minimum tray width, we refer to Table 392.22b(1) of the NEC, which provides allowable cable fill areas for single-conductor cables in ladder-type trays. Based on the total outside diameter of 22.53 inches, the next standard tray width that accommodates this size is 24 inches, 600 millimeters. Therefore, the minimum width required for the ladder-type cable tray is 24 inches, 600 millimeters. However, according to Section 392.22b(1)(a), the cables can be bundled together to form each circuit group. In this case, the minimum tray width can be calculated by multiplying the overall diameter of the cable, 1.502 inches, by 10. As each circuit will consist of one phase at the top and two phases at the bottom, the required width is 15.02 inches. Therefore, the minimum ladder-type cable tray width for this configuration would be 16 inches, 400 millimeters. This example demonstrates that bundling the cables together to form each circuit group reduces the required cable tray width, making it more economical compared to the single-layer installation. Additionally, this configuration helps to reduce or cancel out the magnetic fields that cause induction and eddy current heating, providing further benefits. Subsection 392.22b(1)(b). If all the cables range from 250 kc mil to 900 kc mil, the total cross-sectional area of all single-conductor cables must not exceed the maximum allowable cable fill area specified in Column 1 of Table 392.22b(1) for the corresponding cable tray width. Going back to Table 392.22b(1), this table provides the maximum allowable cable fill area for single-conductor cables rated 2000 volts or less installed in the ladder, ventilated trough, or wire mesh cable trays. The table is divided into two key columns. Column 1 is for cables ranging from 250 kc mil to 900 kc mil, which is under subsection 392.22b(1)(b), while column 2 is for 1000 kc mil or larger single-conductor cables, which are under subsection 392.22b(1)(c). The rows in the table list the inside widths of the cable trays, ranging from 50 mm, 2 inches, to 900 mm, 36 inches. For each width, the corresponding maximum allowable fill area is provided in square millimeters and square inches. For instance, we have 3 sets of 3 250 kc mil cables, 3 sets of 3 350 kc mil cables, and 1 set of 3 750 kc mil cables, all are THW cables. What is the minimum width required for a ladder-type cable tray? The cross-sectional area can be obtained in Chapter 9, Table 5, or from the manufacturer's cable catalog. If the catalog does not provide this, it can be calculated from the overall outside diameter. A 250 kc mil THW cable has a cross-sectional area of 0.6291 square inches. With 9 of these cables, their total area is 5.662 square inches. For 3 350 kc mil cables, with an area is 0.787 square inches, giving a total of 7.083 square inches. The 750 kc mil cable has an outside diameter of 1.4272 inches, and its cross-sectional area is 4.281 square inches. Adding these areas together, the total cross-sectional area of all cables is 17.03 square inches. Referring to Column 1 of Table 392.22b(1), since 17.03 square inches falls between 16 and 18 square inches, an 18-inch, 450 mm, wide ladder-type cable tray is appropriate. With 17.03 square inches of fill, there is still space for an additional 0.974 square inches. This means that more cables, ranging from 250 kc mil to 900 kc mil, can be added to the tray as long as their combined cross-sectional area does not exceed 0.974 square inches. Subsection 392.22b(1)(c). When single-conductor cables that are 1000 kc mil or larger are installed in the same cable tray as single-conductor cables smaller than 1000 kc mil, the total cross-sectional area of all cables smaller than 1000 kc mil must not exceed the maximum allowable fill area calculated using Column 2 of Table 392.22b(1). for the corresponding cable tray width. This subsection combines the requirements of subsections 392.22b(1)(a) and 392.22b(1)(b), which pertain to cable trays containing a mix of 1000 kc mil or larger cables alongside smaller single-conductor cables. According to this subsection, the total cross-sectional area of all cables smaller than 1000 kc mil must remain within the maximum allowable fill area as defined by column 2 of table 392.22b(1) for the specific cable tray width. Let's go back to table 392.22b(1). In column 2, you will notice that there is a superscript A and B. We can refer to the note below this table. What is meant by these superscripts? For superscript A, this is the maximum allowable fill areas in column 2 shall be calculated. For example, the maximum allowable fill if a square millimeter is to be used for a 150 mm wide cable tray in column 2 shall be 4200 minus 28 multiplied by SD. If square inches is to be used, the maximum allowable fill for a 6 inches wide cable tray in column 2 shall be 6.5 minus 1.1 multiplied by SD. While superscript B is the term SD in column 2 is equal to the sum of the diameters in of all cables 507 mm 2 in inches of all 1000 kc mil and larger single-conductor cables in the same cable tray with small cables. To understand this, let's have an example. The cables that will be installed are 3 sets of 3 1000 kc mil cables, 3 sets of 3 250 kc mil cables, 3 sets of 3 350 kc mil cables, and 1 set of 3 750 kc mil cables, all are THW. What is the minimum width required for a ladder-type cable tray? For the cable tray installation, cables 250 kc mil to 900 kc mil have a total cross-sectional area of 17.03 square inches. For cables that are 1000 kc mil or larger, the total overall diameter is 13.518 inches, which we designate as SD in column 2 of the table. To calculate the maximum allowable fill area, we use the formula from column 2, where the maximum allowable fill is 1.1 multiplied by SD, resulting in an SD of 17.542 square inches. By adding the 17.542 square inches from the smaller cables, the total fill area comes to 17.542 plus 17.03, equaling 34.568 square inches. Note that this sum is over the limit of 32.5 square inches, which is the maximum permitted fill given in column 1 for a 30 square inch wide cable tray. Column 1 shows that a 36 inches wide tray, with 39 square inches fill capacity, would be required for the 34.568 square inches determined from the calculation of column 2, table 392.22b. Therefore, to accommodate the 34.568 square inches of fill, a 36-inch, 900 mm wide cable tray should be used. Please note that the ampacity of cables rated 2000 volts or less in cable trays must comply with the requirements specified in section 392.80a. Thank you all for watching.